Welcome to yet another video of the BRICS Astronomy Research YouTube series, the place where we dive deep into research that researchers across the BRICS countries are currently embarking on. I'm your host, Mulibokol Kulwani, and I'm pleased to have you with us today. On today's episode, we have something truly special for you, and I know you'd enjoy. We have a researcher from one of the BRICS countries that form part of the BRICS Intelligent Telescope and Data Network. If you have never heard about this, please go on to our webpage, which is www.bricsastronomy.org, and find out more about this initiative. Our guest today will briefly highlight their expertise and achievement. Without any further ado, let's jump right into it.
Okay. Thank you very much for your invitation. Just as I send a few documents or the files, there's a summary of my research project and my role under the Space Science and the Geospatial Institute and the development of astronomy in Ethiopia. Just to summarize my role and my research work, the current research work, and on which areas I focus to my work, and then I will just to present the presentation. Actually, the development of astronomy in Ethiopia and the East Africa region, where I put my title like this one. My institute is the only institute in Ethiopia for astronomy, astronomy and astrophysics departments has own a curriculum for master's and the PhD program, not for the BSc program, undergraduate program. That is why I put here the development of astronomy in Ethiopia and East Africa. So over the highlight of my leading teaching and leading teaching and research roles in SSCGI, Astronomy and Astrophysics Department. Here I will present my presentation in part 1, part 2. Part 1 is my role. Part 2 is just a summary of my research project. Under my role, overview of astronomy and astrophysics, what astronomy currently conducts under the Space Science and the Geospatial Institute. My role, teaching, research and supervision, student supervision, and outreach activities or public outreach activities. The summary of my research project, the few of them, not all in all. I have more than 14 publications and more than 20 certificates. Just I didn't include my certificate actually. I included a few of my publications with my students, and I will present a few of my research results here for staff members, for MSc students, for PhD students. Under this category, astronomy currently conducted the postgraduate program, research, outreach program, observations. And under the research, we have 4 thematic areas: stellar astrophysics here. The stellar astrophysics, the thematic area is solar astrophysics, cosmology, and extragalactic astronomy. These are 4 basic thematic areas under astronomy and astrophysics. We conduct the research through those against those thematic area, and also the supervision of MSc and the PhD student. Under astronomy, what is the human resource, the capacity of human resource under the department? 2 PhD and 1 MSc in stellar astrophysics, and 1 PhD and 1 MSc in extragalactic astronomy. Actually, Dr. Mariana, if you know her, she is now at Spain. Now she moved to there. Previously, for over 8 years, she was here under astronomy and astrophysics. Now currently affiliated with our department or our institute and working on extragalactic astronomy in terms of supervision, outreach program, and research work activities. And then instrumentation, those who are just currently operating the telescope, 1 MSc in electrical engineering, 1 MSc in electrical, actually the mechanical engineering, I'm sorry, 1 BSc in mechanical engineering and the software engineering. And we have 3 females, those who are voluntarily working with us in astronomy and astrophysics, 3 MScs in cosmology, 1 stellar, the solar astrophysics. In general, we have 9 staff members actually. Those 3 are not just under the government employees. Actually, they are supporting us in terms of research, in terms of outreach program and other activities or the routine activities, except the teaching and the supervision and like the research or data analysis or some what actually they are working on their research or their master's titles to publish. They are working on that areas. So we have collaborators, the international and the national collaborators. Under international collaborations, we have South Africa, Northwest University, Russia, Spain, Chile, USA. And national collaborators are Addis Ababa University, Adama Science and Technology University, Mekelle University, Jimma University, Bahar, etc. So actually, the main collaborators are the international collaborators because we have experts really from Russia, from South Africa, from Spain, Chile, USA, and so we are working with there in terms of supervision, student and PhD and the master supervision, and the capacity building, especially on computational like Python, IRAF, and so on. This is our main collaborators. So my role is oversee the department activities and the strategic direction for just not as an institute, as a national. I'm just oversee or controlling all the activities carried out under the department, fostering a collaborative environment that encourage innovative research and the students' engagement from the government, the public, and the non-government organization. People are just running to us, and we are just coach to them to teach or astronomy or just to participate in the astronomy and astrophysics. Leading research projects while supervising students and guiding their academic progress in my institute and different universities that I already mentioned. Not only that one, is more than 4 or 5 universities. I was just engaged to the supervision of MSc and a PhD student, teaching, conducting courses in computational astrophysics, like Python, TOPICAT, Fortran, enhancing students' programming and analytical skill. Actually, not only this one, I was teaching for last 5 or 6, 7 years advanced physics courses. My BSc is applied physics, my MSc is quantum field theory, my PhD is astronomy and astrophysics, particularly in stellar astrophysics, on binary stars and the mass transfer, dynamical effect of mass transfer in binary systems. So just I have familiar with the advanced physics courses, and I was teaching those courses, particularly in astronomy. There are a lot of courses I was teaching, like stellar structure and evolution, physics of compact objects, high energy astrophysics, and so on. Supervise student research projects, guiding their academic progress. And my research and the supervision carry out stellar astronomy research with emphasis on mass transfer, binary stars, binary star catalogs, like the catalog of eclipsing variable stars, compact object, white dwarf binaries, neutron white dwarf binaries, and so on. I was working on the computational theoretical framework or mathematical formulation plus the observational data. Observational, when I'm saying the observational data is compiling, downloading the data from different surveys and then to validate the theoretical predictions. And also I'm familiar with MESA, module for experimental stellar astrophysics, and also physics of eclipsing binaries. And I'm just familiar with that to work my research and advising my MSc and the PhD students. In addition to participating in the research initiative, I coach students through their research endeavors, oversee their academic progress under the department and the different universities, our collaborations with the national collaborators and outreach programs, as I already mentioned. Here is the summary of research in stellar astrophysics. I'm a PhD holder, just finished my PhD in stellar astrophysics, as I already mentioned. The main members of this team or this group is PhD and a professor, including me, Dr. Gammachu. He's a star formation rate and star formation and evolution, and also the planetary system. Dr. Tasfai Danya is already working on the variable stars. Dr. Ikdem Mangasha is working from Makale University, is working on binary stars and the catalogs. Professor Oleg is just our collaborators from Russia. Dr. Sergi, is a real scientist, currently is advising our student, PhD student with me on exoplanets. And MSc staff members, including our student here, it's more than 14 members under the stellar group. This is excluding the extragalactic cosmology and the solar astrophysics. Actually, in solar astrophysics, we have 2 PhD in collaboration with Makale University and Addis Ababa University. We have the MSc holders under solar astrophysics. In cosmology, also, we have a collaboration with South Africa, Northwest University, Professor Amara, Dr. Shambal, and Dr. Ramuddin. So we are working with them. Extragalactic, I already mentioned to you, Dr. Mariana, she is really the handwriter of our institute, and even for the Ethiopia and Africa as well. If you know her, she is actively participating in the research and the public outreach programs or development of astronomy in Africa and the globe as well. And here is some research, summary of research in stellar astrophysics and activities done in the past year. One is a theoretical model of mass transfer in Algol-type eclipsing binary, mathematical, and the catalogs that I used to work on this one, and that more than 4 students graduated using this under this title, observational class, the theoretical framework. This is the results that I already published with my advisor, Dr. Salomon, on the International Astronomical Union, the Cambridge University Bridge as a proceeding paper, plus I'm also one of the editor of that book that's already published, IAU 356. And the formation and the evolution of binary systems from stars X-ray to binaries. This is the ongoing project. The member of this project, I am on the copy of this project. It is this project is just the knowledge transfer project. There are members of more than 6 members is here. I only put the PI and the copy of this project. And currently this project is ongoing. I didn't put the result of this project because the institute funded this project, and I'm working with national and international. Actually, Professor Oleg, I'm working with him on the specific topic, the variable stars. That is ongoing and close to submission for the publication. Evolution of closed binary systems, parameter distributions. This is with my colleagues. Ugasa is my PhD student, PhD candidate. Actually, after 2 months or 3 months, he will finish this PhD. He's working on the resolved spectroscopic binaries. And this is a project that I did with him, with Professor Oleg. And the B4 MSc students, the first one is angular momentum evolution of binary blue stragglers from the globular and open clusters, M67 and M13. We are just to download the data from different surveys, SDSS and the Vizier. She was working, this is the female, my MSc student. Actually, she was finished this MSc in 2022, and she published one paper from this thesis. And this is the results that we obtained to investigate the orbital and the stellar parameter or the physical parameters of the blue stragglers due to the gravitational interaction that can be managed, how the internal properties of the stars in the blue stragglers, how they are formed in the closed binary systems, and what is the effect of the gravitational forces on those stars. And beside of that, the orbital dynamics of the stars in the blue stragglers, and the main important how the angular momentum is changed for conserved angular momentum and the non-conserved angular momentum, via the physical principle of Roche-law overflow. If two stars is gravitationally bounded and one is filled, the Roche-law and the transfer from the donor to the accretor, and there is the accretion stream that is formed, and what is the gravitational time scale. Even we studied about the gravitational time scale on this title, and actually on the clusters we published one paper from this thesis. This is the result that I mentioned for just as a sample. I put the results for the orbital distribution of the orbital parameters for angular momentum, for mass of the donor stars, actually for the physical properties of the stars in blue straggler stars, considering M67 and M13. For the second, the long-term evolution of the contact binary systems, the WMA. This is actually the typical example of the eclipsing binaries. We have studied about the stability of mass transfer in contact binaries. Also, she was working from the airport. She has a self-sponsored, and she published on this thesis on the physical properties of the W-type, WMA-type contact binaries in different cases, the A-type, the W-type, the B-type, and we have studied the physical, the internal properties of the stars in the contact binaries. Actually, I've downloaded the catalog from different surveys, and we have seen what has been and has not been studied in that catalog. We identified the stellar parameters and the physical, the orbital parameters. Once we identified and we studied the interaction between the two stars, whether they are contact binaries and semi-detached binaries, over contact binaries. Actually, this is the contact binaries, and we have deal about the mass luminosity relation, mass temperature relation, and the mass radius relation to study the internal properties of the stars in contact binaries by using the polytropic models, actually. And this is the results what we have found. This is a published paper from this thesis. This is the title of the thesis, MS thesis, and this is the paper the specific objective of the thesis, what we published in research astronomy and astrophysics. This is orbital evolution and the physical properties of eclipsing binaries in the original Kepler field. Using the original Kepler field, we studied about the relationship between the orbital parameters and the stellar parameters using the polytropic models and the binary stellar evolution models. As you see here, from these figures, the black from the left one, the black one is for the accretor, the distribution of the accretor is, the black one is the distribution of the mass of the accretors for orbital period less than 0.2. The blue one is for the orbital period is greater than 0.2. For those stars having the orbital period less than 0.2, even their age is greater than the age of the universe. In principle, that is wrong, but we have studied. Maybe we have just to finding as a question mark. Even the reviewer, when we studied, we already sent this submission. I think it is submitted to one of the journals. It is under review. They asked us why it is just to the stars have ages more than the age of the universe. It's around 14, 15, around even 18 for those who have 0.08 solar masses. So we have studied about the internal properties of those stars in the eclipsing binaries using the original Kepler field. And we have studied this, and actually we already submitted this paper. We are working on the first reviewer comments, and once we finalized, we again submitted to them and for the publication. This is a paper, close submission for the second revision. For MSc, again, evolution of post-common envelope binary systems parameter distribution. This is also the properties of the main sequence stars and the white dwarf stars. White dwarf as accretor and the main sequence stars as the companion of the main sequence as a donor stars. We studied the properties of those stars using the polytropic, the gravitational radiation, the physical principle of Roche-Lobe overflow. In case of conservative and non-conservative, in case of non-conservative, the mechanisms that additional mechanisms that lose orbital angular momentum from the systems when the two systems is gravitationally bounded in terms of the gravitational radiation and the magnetic braking. We developed some mathematical formulation and we have did a paper. This is the result that we obtained. Actually, we ready the paper to publish, to send on the astronomical notice. I think the publisher is Wiley. So soon we will submit this for the publication. I hope we did a lot and we published this one. For the PhD program, this is, as I mentioned, one of my colleagues, Rugasa, he has two publications, excluding his PhD publication. So this is one of his PhD publication. So he did on orbital and the physical parameter of resolved spectroscopic binaries. So as I earlier mentioned to you, almost he finalized his thesis and he will submit to the department thesis after 2 or 3 months. Now this is the result of his PhD thesis and the evolution of binary stars. This is my thesis that I already finished in 2019. That is part of the eclipsing variable stars. I'm using the catalog of variable stars, catalog of Algol systems, and some mathematical formulation. I was did some trick or this computationally using the Python, Fortran, and the TOPCAT for some data manipulation. And this is the result that I obtained from the catalog of eclipsing binaries. In that case, I did the relationship between the theoretical models of zero edge main sequencing, terminal edge main sequencing, and the post main sequence at the giant, and the subgiants. What the physical properties of parameters of stars in the eclipsing variable stars at the zero edge main sequence, at the terminal edge main sequence, when they are evolved of the main sequence as giant, subgiant, what really it is just to indicate it shows to us and what is contributed for the scientific contribution. That's the result what I obtained during my PhD thesis. This is a few of my research, summary of my research projects with my project as well as my MS and the PhD students. Also, I didn't include it for those PhD students who are working on the exoplanet with Russian astronomers. So this is the summary of what I put here. The project, 10 project is currently running. Some of them are just to complete it, some of them are ongoing. For MSc students, 4 projects is already completed. For staff members, this is the currently running project, not the completed one, actually. For more than 18 publications are produced under the stellar astronomy. As a department, it's more than 115, more than, I think it's more than 150 or 60. So 11 MSc students are graduated, 2 males and 9 females. Actually, we are just really eager to work on the female participation in science through astronomy. 4 PhD students are graduated, 4 of them are males. 4 PhD students all in a good progress again, 2 females and 2 males. 4 MS students in a good progress, 1 male and 3 females. And the data that we are using for those projects, the Vizier, Simba, the Gaia data release, and other surveys using the Fortran, Python, TOPCAT, and also IRAF is one of for the data reduction. The general objective is, as you know here, as a researcher, can gain the deep understanding of the universe's structure and the fundamental of process governing the stellar and the galactic formation and the evolution. Also, this thematic area is just to collaboratively scientific contribution in the study of binary stars and the mass transfer can significantly benefit the astronomical community in several ways: the data sharing, resource collaboration, interdisciplinary approaches or different, like the relativistic astrophysics or cosmology, cross-institutional research in national or international, publication and the dissemination for the community, and the networking approach, opportunities for working to get some collaboration or conference, and so on. This is all. Yeah, you.
Yes, Dr. Seblu, thank you so much. I think this is way more detailed than I imagined we'd go into the research, but this is wonderful. I guess it gives us like a clear picture of the kind of research that you're into and the research that your students are currently engaged in, right? So I have with me Narusha here, who will I think we'll touching on aspects that you presented on, as well as the summary that you provided us with, right? And what we wanted to then get from this is just a discussion, maybe touch base in terms of aspects that you touched on briefly, and maybe just need more elaboration on that, right? But maybe just to start on a much more broad question, right? I mean, you're well established within the structures of astronomy in Ethiopia, right? But maybe you can tell us more about your journey in astronomy and what sparked your interest in studying stellar astronomy.
Yeah. That's a good question. In Ethiopia, actually, we have more than 45 universities, and the only one institute is the Space Science and the Geospatial Institute. Under this institute is only astronomy and astrophysics as its own curriculum for MSc and the PhD program. And this institute has a dependent curriculum, and the degree is awarded by Addis Ababa University. Maybe you know Addis Ababa University is the leading university from the Ethiopia, the first batch of the university. So our student is a master's and the PhD is get the degree from Addis Ababa University. We collaborate because research institutes cannot give the degree for the student. So astronomy is already started in 2015. Actually under Dot Observatory and the Research Center under the Space Science, the former Institute, Ethiopian Space Science and the Technology Institute. And now the Ethiopian Space Science and the Technology Institute is merged with the Geospatial Institute, and make it is the name, the Space Science and the Geospatial Institute in Dot Observatory as it is. The 4 department under that it's affiliated with Addis Ababa University, and they give the degree award for the MSc and the PhD program.
Yeah.
So starting from 2015 up to now, we graduated more than around 10 PhD students and 22 MSc students in all, in 4 thematic areas. In solar astrophysics, two PhD. In stellar astronomy, it's around 4 PhD and MSc as well. In extragalactic, 2 PhD, 2 are just ongoing. And in cosmology, 2 PhDs already graduated, and 2 MSc, and so on. So in all, 22 MSc and 10 PhD were graduated under the department. And currently in Ethiopia, we are working on kids, Ethiopian space kids, to engage, to participate or motivate the kids, especially from grade 1, from KG, or from this actually from KG. KG means just before grade 1. From that up to the higher officials from universities, we are just to give the training for those. We have a gap. We have a gap in a space program. So this is the institute has a mandate to give the training for those who are engaged to astronomy and astrophysics, or even for physics. So we have to encourage people or students to learn physics, unless otherwise we cannot catch up with the astronomy and astrophysics. It's difficult because I just, from my understanding, so we have give the training for the students to just to move to the physics, and then we can get the students through the physics in astronomy. So we are working on that area, and public, we have 3 telescopes, 11-inch telescope for outreach program, and 1 meter diameter telescope, the huge one, the optical telescope for the scientific. So we are using this. Actually, that is already spending. It is a function operationally. It's working.
Yeah.
For the compound is now under the maintenance. Once we finish that maintenance, we can continue to take the data with South Africa, also with Russia. The Russian astronomers are just to play a role on this astronomy,
Yeah.
and also Astelco, maybe if you know. This is a Astelco's brand, the telescope is. So we are using those telescopes and just working on the scientific contribution. Actually, and beside of that, we to teach the peoples of the physics and beyond that about the astronomy and the space program in Ethiopia using the 11-inch telescope. We have three the computerized telescope. So this is the source that we have. And also we are working on the site selection. And Dot Observatory is one of the selected sites. And the Lalibela, maybe if you may know, this is at the best site selected. And now additionally, we are working on around 48 mountains. Still now we are working on that one, maybe due to some situations, complexity situation. We are not finalized that project. Maybe for the future, we finalize this and to select and put for the astronomers, the site selection for the astronomers. This is all that what we are working on, astronomy in Ethiopia, the development of astronomy in Ethiopia. Regarding the collaboration,
Yes.
we have a lot of collaborations. Even Leiden University, we are working with them in terms of capacity building,
Yes.
competition. On solar astrophysics, maybe if you know, maybe Professor Nats is from NASA. He was just advising our PhD student on solar astrophysics, and maybe now currently he moved his position to maybe the administrative professor. Brain Chauer, he is a really scientist from the Dartmouth University from USA. He advised me on the MESA module for experimental stellar astrophysics. He's a scientist. Again, from Russia, as I already mentioned, Sergey and others, Oleg, Leonid, Leonid, and
Yes.
those
I
are,
guess.
yeah,
So please go on.
yeah. Okay, this is all. Yeah.
Okay, that's all. Okay, no, I guess maybe my next question was to touch on collaborations because in your presentation you highlighted the importance of collaborations, and I guess BRICS Astronomy in its essence is just a collaborative space among these different countries, right? And but you already answered my question, but my question was centered around in terms of how important are these collaborations that you have engaged in terms of making sure that astronomy grows in Ethiopia and actually produces the best science that you can produce. But I see that you touched on all of these different aspects of it. But I guess maybe we can then move on from that. And I think you also touched on different astronomical facilities that are currently in progress in Ethiopia. I think that's great progress because
I missed that. Yeah.
Yes, because I think for the BDITDN, which is the BRICS Intelligent Telescope and Data Network, I think that those telescopes would be very crucial in terms of integrating them into the network itself, right? But my next question would be about because I mean you mentioned a lot about the students that you have, right? And one of the key critical skills that we often have, or maybe supervisors can give to the students, are critical thinking skills, right? But then my question would be, I mean you teach computational astrophysics using Python, right? So you mentioned TopCat and Fortran too. So how do you adapt your teaching methods to ensure that students are not only able to just do Python, but also are able to then develop critical thinking skills?
Yeah, actually, not only those tools, actually we're using the IRA for the data reduction. Yeah, a bit. Yeah, I'm busy with different roles, as I already mentioned. Regarding the computational part, that is very important. Without computational for the application is nothing. So it is very important. We need some expertise, especially maybe more than maybe beyond advanced way, we need some collaboration. So we're going to give the training on the computational, especially nowadays about the IA is just to dominate everything, and also the machine learning, the deep learning. So we have to focus on that. The backbone of the Python, very important. How you can just to handle even the principal component analysis using those models, how we can just to use the machine learning, deep learning for astronomy, using the Python, and how we can just to manage the research. Those are very important points. We are just to collaboratively work together. Currently, we are just to using the Python and the Fortran for data generation. When from the different survey, we're using the Fortran to generate some data, or Python for some numerical simulation, or some numerical mathematical analysis using some models. We developed some mathematical formulation, and using the mathematical, we can just plot or make some simulation. Rather than that, we have to do on the machine learning and the deep learning, how is that can just to give the scientific configuration or scientific contribution, how we can just to express. Maybe we have to do on that one. I'm looking in that direction. Maybe I don't know from your side, from the team side, we have to discuss on that one. And,
Of course. I think there are societal benefits that we're also thinking around, centered especially around these skills. I think maybe we can have a discussion around this too. Yes, 100%. I think Narusha, I don't know. Do you have any question?
Hi. Thanks for the talk. I just have like more of a scientific question, I guess. You spoke about like stellar parameters for binary stars. What does this tell us, and like in a general sense, for people who don't have astronomy background, let's say? And then can you discuss like the challenges you faced modeling mass transfers, specifically in the mechanisms with the catalytic variable stars, but like in a very basic way and not too scientific?
Just to make clearly, I'm working on the stellar astronomy as a stellar astrophysics. The stellar is not just a single, not only the binary stars, there is also a single star formation, evolution for single and the binary stars, and also the planetary systems. How maybe the question is, maybe if I understand your question, how maybe to understand how you can just to teach the people and how this is the importance of that especially for the formation and the evolution of the galaxies, the formation properties of the galaxies and the extra galaxy or the other galaxies in agent, and also the black hole, the compact object. Maybe if we can go that way, we see maybe if I understand your question in that way. Yeah.
Okay, and then if you look at the current evolving machine learning tools and how this may affect your studies or your student studies, and even artificial intelligence, what complications or limitations do you think this would bring into like astronomy studies?
Yes. Very good. Yeah, it's a nice question. So, yeah, we have to think about that one. Maybe if people are just to rounding around the AI, the machine learning is another method, but AI is maybe people are just to be lazy in research. If we are just always searching just as a support, we can just to use that one. AI is very important, but we have to keep how the people are understanding to generate from his mind to new ideas, brings and new ideas for the research. Currently we are around 4.5 or 5. So how we can just handle those? We have to really eager working at this moment, we just people, my student or PhD, MS student, they are just using that one. I'm advising them just they are self-independent rather than just to depend on the AI. So really, we have to just to give some training in collaboration for the students, nationally and internationally. We are working together, and how we can just to go, how the universe in the universe now currently, how the research is going on in beside of the AI and the machine learning. So we have to look into it, and then we have to just advising and teaching, doing our research in a good manner way.
Okay, thanks for that. I guess more towards your own research and not necessarily for your students, but what project you like to work on if you had infinite time? Like if you hadn't to focus on anything else, what project would you want to work on?
For future or now?
Now or the future?
Yeah, just really interesting on the star and the planetary formation and the binary star formation and evolution, the theory of the mass transfer and the exoplanets. So not all, just it depends on the interest of the students. My interest, just from my side, or actually I'm working currently at the formation and the evolution of the binary stars from X-ray to the X-ray binaries, and also the cataclysmic eclipsing variable stars. I'm working on that with Professor Oleg. I'm just go ahead with that one and continue that one. Beside of that, I'm working with my colleagues on star formation and star and planetary formation and how it looks like. I'm working on that one. I will work on that one just by planning for the future.
Okay, great. Lebu, you have any question?
No, actually, I think from my side, I think most of my questions were answered during his presentation, right? And I think he gave a very clear presentation and overview of the organization and the research that's happening in Ethiopia, right? But from our side, Dr. Seblu, I think before you conclude, we have one last question that is outside of the science, right? But maybe just to in else just getting to know you as a person, right? I think the first question would be if you were to travel, right? Where would you go if you have infinite money? Where would you go? What's the first place that you go?
For now or future?
I mean, for now or the future. Any.
Yeah, maybe I need. Just I don't know. Even I'm trying to just to searching the research visit at the CAS, Chinese Academy of Science.
Yeah.
South Africa. I want to just to see. I didn't just to get some opportunities to see the South African observatory.
Yeah.
I was in Leiden University. That is really it is it's beyond imagination what is there. How the science is there. Maybe if they go there. So yeah, that is impressing me when I was there last year in June 2024. I was there. I learned a lot of information, a lot of things about how to manage the science, how the science is doing everything. Globally, that is very important. That's what I learned from the Netherlands, from the Leiden University. So like that, I want to know even USA, Russia, China, even South Africa. So just, I don't know, maybe from Uganda and Rwanda, I was writing an email to just to maybe to work together in collaboration. There are some colleagues I have from Uganda. I don't know if there is some opportunities. I was to just to advise some students from there. Mariana is working from there to giving some courses from stellar part. Maybe if they are interesting, I am communicating Isaac, if you know him, and Joseph from Rwanda. So if there is some opportunities there, I will just to extend my network to work with them. This is all. Also, I was in Thailand, Chiang Mai. I was Chiang Mai Observatory. That is really important. I was there and I'm observing, and I learned a lot about observational. So this is all the previously my visit or my observation. And now for the future, I will try to again and again, I will just to visit and learn a lot.
It seems as if it's difficult having to separate your travels from the astronomy part of things, right?
Yeah.
But maybe one question before we let you go is that if you were to put if you were given infinite money and you were able to put a telescope in anywhere in space or on Earth, I mean, what would be the best position or where you think a telescope would be best be based in space or on at the back of the moon?
Telescope in space is very important. You see Hubble Space, what Hubble Space Telescope is, and what with the James Webb Space Telescope. That is very important. Rather than putting in the ground, space is has no question. Yeah, we have to.
Do you have a place where you want to put that?
Yeah, I hope maybe. We do. We have to work together in BRICS. Group. We have to just to fight and then we have to win. It needs, resource. It needs a resource. So if we work together, I think we will do the best.
And then one last question. I think this is mostly difficult one. But then, what is the last song that you listened to?
What?
The last song that you listened to.
Last time?
The song in terms of music.
Any music. Yeah.
You listen to Jay-Z?
Actually, I didn't listen because I'm investing my time on the research. Maybe just I didn't just to ignore any music. I'm just Actually, I'm not a listener. I'm not follow because my time is I invest. I kill my time on the research and
on research. Yeah.
Okay. I didn't prefer because I don't know which one is best, which one is. It is difficult. Yeah.
I see. No, Dr. Seblu, I think from our side, from BRICS Astronomy, we are more than delighted to have a chance to have a chat with you to discuss your work, to discuss the research that you're going, and you're such an amazing person. So we really appreciate your time. We really appreciate you taking the effort to meet with us. And we'd love to say thank you very much. And I think this is the first of many, right? We'll be building onto the relationship moving forward. And maybe sometime we'll have a chance to interview one of your students and sit down with them. I know a couple of them are coming to the AFOS conference so we really appreciate your time and effort for this interview.
Thank you.
Thank you so much.
Thank you. Have a nice.
Bye.
Bye.
What an incredible conversation we've had with our speaker. I hope you found that as insightful and as inspiring as I did. Thank you for tuning in with us. I hope you enjoyed this episode. Don't forget to like, share, and subscribe so you never miss out on amazing guests that we have on the show. I'd love to hear your thoughts. Drop a comment below and let us know what your favorite takeaway is from today's discussion. Until next time, stay curious and we'll see you on the next episode.